Hi there, this is Year 13 Maths Mechanics lesson again, exercise 19b. We've done a bit of mechanics already, but I'm going to start initially today with looking at the Suvat equations. We've seen these Suvat equations before, sometimes called the constant acceleration formulae, but today we're going to do this with vectors, so it sort of ramps it up a little bit. Interestingly, I've got this off a slide, and there's one equation missing. And that's what the initial thing is, which of these 5 Suvat equations are missing. And it's not the obvious one. When I first looked at this, I thought, oh, it's this one that's missing. This is the equation they don't give you in physics. They give you this one. That's number 1, that's number 2, that's number 3, but there's one more. And the 4th one, in addition to number 5, which I was expecting them to be missing, the 4th one is v squared equals u squared plus 2as. Hopefully you remembered that one. By the way, they're the 5 Suvat equations that we're going to need. A particle accelerates, this is a starter, uniformly from 3 to 7 meters per second whilst covering a distance of 60 meters in a straight line. Find the acceleration. Suvat will help us do this, so I'm just going to write out Suvat. I personally always write it out like that and then try and fill in the gaps. Now I know it starts at 3, goes up to 7. It does it in 60 meters, and I want the acceleration. And so I haven't got that one, so the one I talked about just now is the one I'm going to use. V squared equals u squared plus 2as. What's the chance of that? Well, I didn't plan it, so I wonder if someone else did. So it goes 7 squared equals 3 squared plus 2 times a times 60. Or said a different way, 120a is 49 minus 9 is 40. So I reckon A is a third of a meters per second to the minus 2. And they got 0.333 in the answer, which is clearly the same thing. So yes, that works. A particle starts with initial velocity 3I minus j. So straight away now, I'm going to do Suvat, but it's going to be a little bit more complicated because I've got to write vectors. So it's 3 and minus 1 for the initial velocity. V equals A equals, after 5 seconds, t equals 5. It moves with velocity 1.5, 2. Now notice I personally prefer writing these as column vectors. Find the displacement and the distance from the initial position at this time. Okay, let's find the displacement first of all. The distance, by the way, that sounds to me like a bit of Pythagoras is required. So this is the one I'm after. I'm not interested in this. This sounds to me like then S equals a half of u plus v times by t. That's one of the other equations in my list at the start. So if that's the case, S equals, well, what's u plus v? I can add these together. So it's a half of, as a column vector, I've got 4.5, and I've got 1, and I've got to times that by 5. So S equals, 5 times that is 22.5, which is therefore 11.25. Oops, just turn on my calculator. I don't want to make any daft mistakes, so I might as well do it properly. Which is, yeah, so written as a fraction, it's 45 over 4, or 11.25 as I said. And this one's got to be just, well, it's 5 divided by 2, which is 2.5. So that is the displacement. That's the first bit done. The distance is, well, you think of it as it's moved 11.25 this way, it's moved 2.5 up in the j direction. And this is the distance I want to find. It's Pythagoras. This is what I was talking about at the beginning. So it's the square root of 2.5 squared plus the 11.25 squared. So square that plus 2.5 squared equals square root the answer, and I get 11.52. So actually, was it 5.2? Yeah, 11.5 meters. It was quite an easy question. See if the answers agree. This person's written it as I's and J's. You don't have to, you've got a choice, up to you. I'll put meters there, make it look like I knew what I was doing. And 11.5 has worked. It's not exact, but it's the 3 sig figs is correct. A particle moves with constant acceleration. So they tell me the A. So again, I want the right suvat. But when I'm having to do this, I noticed last time I had to give myself a bit more space because I've got the right vectors. Constant acceleration is minus 1.5 and 3. It is initially at the origin and its initial velocity is 2.5. There's my 2.5. Find the time when the particle has a position vector 1, 4. And this is what I want. I don't care about the v. So this sounds like s equals ut plus a half at squared. So again, we're going to write 1, 4 is the s, equals the u times by the t. Well, that's 2, 5 times by t, plus a half of this a, so that's, well, plus minus 0.75 and 1.5 times by t squared. Now theoretically this gives me 2 quadratic equations, so I might as well go with the top one, which says 1 equals 2t minus 0.75 t squared. And the obvious thing is to rearrange that. Minus 2t plus 1 equals 0. And I'm going to solve that on my calculator. Menu, go down to A. It's a polynomial of degree 2. Well, I've got 0.75, I've got negative 2, and I've got 1. And my answer, as it says, is 2 and 2/3. So t equals 2 and 2/3. So basically, in solving this top equation, if you like this bit here, I got these 2 potential answers. So now, the one thing I would say is that we need both components to give me 0. So what we're looking for is one of these answers to be true in both, I suppose. So let's have a go at this. So let's do the, oh, I don't know why I did that. I'm going to do the second equation. So that's 4 equals 5t plus 1.5t squared. Now if I solve that, I'm going to have to do 1.5t squared plus 5t minus 4 equals 0. So let's just do that then. 1.5, 5 and negative 4. And this has given me answers of t equals 2/3, at least that agrees with the last one, and t equals minus 4. Now, as I said, these equations, these solutions have to work for both situations. We need the x-axis kind of component, the in the I direction, to agree with what answers we get in the j direction. And you can see only one of these 2 answers is true in both. And so by definition, therefore, t equals 2/3. That's my only solution, according to me at least. Answers 2/3 of a second. Good. So our last example says a particle moves with constant acceleration starting from the origin. Its position vector at time t is given by that. So okay, I'm going to write that first of all as a vector. I always prefer it as a vector. I'll probably say that 100 times. T squared minus 3t, like that, column vector type. 2t squared minus 15t. How many times does a particle pass through the origin during its subsequent motion? Okay, well if it passes through its... now notice this is the displacement vector. And it says how many times does it go through the origin, therefore that would have to equal 0, 0. So if that is true, the top line, a bit like last time, the top line was going to give us some answers. If we remember on the last question, that was all to do with s as well. I think we use s equals ut. We had a different equation. We use s equals ut plus half at squared. Here I've got just a function. It says this is s, this is in both I and j directions. And it's when does it pass through the origin, so I've set it equal to it. The other equation, of course, is 2t squared minus 15t. But like last time, the answers are going to have to agree. So let's get the answer. This one's going to give me, I could do this on the calculator. It's factorizable. It's quite easy to factorize. This gives me t equals 0 and t equals 3. So there's my 2 solutions there. This one, again, t comes out as a common factor. 2t minus 15. Oh, okay then. t equals 0, but t is a different answer this time. That gets me 7.5. So they've got to agree on both. So in actual fact, it says t equals 0, and that is the only solution. How many times does the particle pass through the origin through subsequent motion? The correct solution then is only once. I suppose it's subsequent motion, not at all. Only once when t equals 0. But I mean, I don't know what the answer says, but it could easily say not at all because it talks about its subsequent motion. Only when t equals 0, I guess. So, look, I've done some questions there. Again, just a reminder that this is missing this, don't know why, v squared equals u squared plus 2as equation. Well, these 5 equations that I want us to use. And that's it. That's quite a nice gentle lesson. Thank you very much.